Hello, my name is Victor. I am one of the product managers at GitLab, and me and my team, we are responsible for GitLab's Kubernetes integrations and infrastructure as code functionality. In this series of videos, likely in 3 videos, I would like to demo you how GitLab can help you if you are an infrastructure engineer, an SRE, or if you are a platform engineer who's setting up automations for your teams, or if you have a good platform engineer and want to benefit from their work. Hello, in this video I want to share with you how GitLab can help platform engineers to automate processes and support their users. We are going to start from the same project where we left off in the infrastructure engineering related functionalities. Actually, everything that I'm showing here could be in a separate project as well. I just put it in the same one for simplicity. Here you might see this project folder, which is actually a Terraform project, as you can see. And within this project, there is a YAML file where users can open a merge request against this repository to edit this YAML file, and they can add snippets like this one. This YAML will define a new delivery project. It has a name, some description, it will have a namespace in the cluster. In this case, actually, I will deploy the application into 2 namespaces in the same single cluster, one called potato head and the other with a suffix of dev. And there might already exist an application project, so they have to provide the path to that project and a few other settings just to configure the project itself. And with this simple configuration, when the user wants to start a new project, they want the everything to be kicked off. They start this MR, you can collaborate on it in a merge request, and afterwards this Terraform project will run. What it does is actually several things. First, it will create the project itself for the delivery project. This is the delivery project. We will speak about it in a minute. It creates a deploy token in that delivery project. This deploy token will be used by Flux to access the OCI images built in that project. We are using Flux with OCI images, not with Git repository, to provide better scaling. But you could use a read registry rights here, and then the deploy token could read the Git registry instead. And we store a project variable within that project, and that environment variable is the agent kube context name for the agent defined in this project here. It will be this project slug and demo afterwards. And we store that there because it will help us to trigger a Flux reconciliation easily from GitLab pipelines. Once a project is configured here, so we create the project. Followingly, we create some infrastructure side things. Namely, we actually just render files here. One set of files is I'm using kubectl. I'm using sealed secrets from Bitnami and the kubectl CLI to store encrypted secrets in the Git repository. You can use any other secrets management solution you want. But what we do here is that we create the secrets in the repo, and then we render it together with a template file that creates the namespace, the service account, role binding, OCR repository, etc., and customization. And finally, there is one more thing that we do, which is we edit the agent configuration in this repository, and we edit it in order to allow all the projects that are defined in that YAML file to access various agent features. So we are sharing this single agent connection with other projects in the GitLab instance. And in the end, once you run this project, what you get are a few things. First, let's take a look at the agent configuration file. This was the base that we started with. That's why we have 2 of them to always know where to start with. And this is the new one. So what we started with included the container scanning, and basically nothing else. The new one, on the other hand, includes CI access and user access as well. And this means that from these projects, GitLab pipelines can access your cluster. while the user access part means that these projects can access your cluster from the GitLab UI. This will be very handy in the environment integration that I will share with you afterwards. Now, to note is that here I'm using the accesses agent, which means that we don't impersonate the GitLab user. You could use here user instead, but then you have to set up the airbag, and as this is a demo, I didn't want it to spend more time on that. And the other set of files that this project creates are these two files, one for dev environment, one for the production environment. Now, as I'm in a single cluster, I put it in the same place, but you could have a separate prod and end subdirectory and have Flux manage those as well in a similar way. And this is that render template that I showed you before. It has the namespace, the service account, role binding, an OCI repository for Flux, a customization for Flux, and here's the sealed secret to access this OCI image. And you can see that this entry point OCI image is in the Potato Head delivery project. That's the project that actually the Terraform project created for us. And that's how you can scale Flux. So with Flux, what you can do that you have a central repository, and then you have other kind of leaf repositories, or rather like branch repositories that can further scale out by pointing to follow-up OCI repository or Git repository sources. So this is what happened in the infra project. Now let's see what happens in this Potato Head delivery project. Here, who owns this project depends very much on your organization. It might be the platform team, it might be the application team. I didn't want to force any of these approaches on you. Both can work very well. As we are going to deploy the Potato Head application, I copied the chart of the Potato Head project under here, and we are going to build an OCI image out of that. Moreover, in the manifest, I have two environments, dev and prod, and in both I have the same subdirectories app and setup. And here I just have a secret. I just added basically to show you that it can be done and how I would do it. And it has all the other Flux resources that you might want to deploy followingly. In this case, it's very simple. It's just a single OCI repository with a single customization that will point actually to that app directory or the OCI image that we build out of that directory. But the whole idea is that you could add anything else as well. You could add other secrets, third-party things, whatever you need. And then in the app directory, we have a Helm repository because we are deploying it with the Helm chart that you have seen. That points to that chart in the same project with the secret that we need. And this is the same secret that was already created for us in the infrastructure repo, because we know that it exists. That's how it can read itself actually. And then we have the Helm release with some values provided. The other environment, the dev environment, is almost exactly the same. I will show you later how one can upgrade these and deploy a new version of this application with this setup. And then basically we have CI YAML to drive all these things. In the YAML, we have a job to build the chart. It will build an OCI image, as you can see, and we store it in the GitLab container registry. The GitLab container registry can store both Docker containers and OCI containers. And then we have a set of jobs to build the Flux-related resources. Again, this is a Flux OCI image that we are building, and afterwards we call Flux to reconcile immediately that OCI repository so that we don't have to wait for the regular Flux reconciliation loop to kick in. And here we just parameterize that hidden job to say where the manifest part is that needs to be pegged and a few other things. That's all what we have in here. You see as well that the production jobs are actually manual. This will allow us a nice controlled rollout into production, where you could set up acceptance, like release management jobs that people have to authorize the release before going to production. Okay. So in the end, what we have is then we will have these container images actually. All these are built from those jobs that you have seen. And this is what we are going to deploy. So once again, to recap, in the infra repository or your platform repository, if you want to have one of those, we point to this entry point OCI image and to the entry point dev OCI image. And from these two, we point to the potato head dev and to the potato head images. Both of these images, we use the same chart, the potato head chart in here, but they will use it with different ham release, different ham values to in the different environments. This concludes the overview for Platform Engineer, and there will be a simple overview and a demo on how this all looks like for the application operator. But before we get there, let me show you something. We have seen in the infrastructure repository that there are environments there for the infrastructure, but those environments were not very interesting for us. Unlike in the delivery aspect, we can already have a Kubernetes overview of that specific namespace that we are interested at. In this case, this is the production deployment and its Flux reconciliation status. And similarly, we have one for the development. It will be exactly the same in this case, so there's nothing to look at, but you got the idea. We can easily have a very quick view of what's happening in the cluster. And this is not for infrastructure engineers, this is more for the application operators, for the users of a platform team, your internal development teams mostly. These same views can be set up later in the application project as well, because the agent is shared with that project as well, as you have seen before. Here I already only created two clusters, a dev and the production cluster, and you have the exact same insights in these projects too. Okay, and now let's go to the next video where I will speak about how your developers, the applications owners, can actually use these processes and deploy a new version.